Alright, so this is Unit 3, the Pythagorean Theorem. The Pythagorean Theorem came from a man named Pythagoras. He lived in southern Italy, and he was considered the first true mathematician. He was also the first to teach that the earth was a sphere and not a square, and it revolves around the sun. So this theorem is named after Pythagoras. So this theorem only works with right triangles. A right triangle is a triangle who has one right angle. Alright, so we need to know the names for the sides of a triangle. We've got the legs. There are always two legs. They're going to be the shorter sides of the triangle. And then they come together and meet at the right angle right here. And then we've got the longest side, that's called the hypotenuse. And this is how you spell it right there. Hypotenuse. And it's always right across from the right angle. It will always be the longest side. And we're going to call leg 1A, leg 2B, and then the hypotenuse always stands for C. If you make if you were to make this side A and then this side B, it doesn't matter. As long as you make sure that the hypotenuse is C, that's the only one that truly matters. Alright, so the Pythagorean theorem works for any right triangle, and the theorem states that the sum of the areas of the two small squares is equal to the area of the large square. Alright, so this just says that whenever you create squares off of a leg of a triangle, so right there we have a square, and then on the other leg we create another square. If you were to find the area of square B and square A, it must equal the area of the square formed from the hypotenuse. Right, so we've got to remember how you find the area of a square. Area is always length times width. So if this square has a side length of 4, we know all the other side lengths are 4. So the area is 4 times 4, which is 4 squared. And we know 4 squared is 16. Okay, so whatever the area of square B is and square A is, combined, it is the total area of square C. So then that brings us, this theorem is then changed into a formula, and this is the formula. This is A squared plus B squared equals C squared. And it's squared because when you find the area of a square, you just take the number of the side length and square it. So this formula helps you find side lengths of a triangle. And this is just how the Pythagorean theorem relates to the real world. And it says that it is used for computing distances between 2 points, such as in navigation and land surveying. It's also used in designing ramps for all sorts of places, such as handicap sites and skateboard parks. So this formula is used in the real world. Alright, so we've got a baseball problem. It says a baseball diamond is actually a square. So even though it's called a diamond, it's actually a square. So here's our square right here. And it says that the distance between two consecutive bases is 90 feet. So we've got to figure out how far does a catcher throw the ball from home plate to second base. So we've got to find the distance from home plate to second base. So we can use the Pythagorean Theorem to solve for this distance, x, right there. So first we're going to create it into two separate triangles. And this is a right angle right here. It's also one right here. But we're going to focus on this right triangle first. We know the two legs are 90 feet, and we've just got to solve for x. So we're going to use the formula a squared plus b squared equals c squared. We're going to say this is a, this is b, and the hypotenuse is always c. So instead of solving for x, we're really going to solve for c. Alright, so we would plug it into the formula, 90 squared plus 90 squared equals c squared. 90 squared is going to be 8100 plus 8100 equals c squared. Alright, so now we've got to do 8100 plus 8100. And when we add these two together, we're going to get 16,200 equals c squared. Right, well, we don't want to know what c squared is. We want to know what c equals. So we learned this in the last unit, that the inverse of something squared is by taking the square root. So to get rid of this squared sign, we're going to take the square root of both sides. So that cancels each other out, and we're just left with c, exactly what we wanted. C is the square root of 16,200. This is the exact answer. So because it's not a perfect square, the exact answer is the square root of 16,200. But if we want to approximate it, that's what this sign stands for, approximate. The approximate answer is that it is 127.28 feet. Alright, so this is how they got that x is approximately 127.28 feet. So they use the Pythagorean Theorem to solve for the distance between home plate and second base, just by using the Pythagorean Theorem. Alright, so the ladder problem. A ladder leans against a second-story window of a house. If the ladder is 25 meters long, so we know this ladder is 25 meters, and the base of the ladder is 7 meters from the house. So this base is 7 meters away from the house. We've got to figure out how high the window is from the ground. So we want to solve for B. I'm going to say 7 is A. B, we don't know. And 25 is C. C always has to be the hypotenuse, the longest side. So we've got to solve for B. So we're going to plug these numbers into the formula. A squared, which is 7 squared, plus B squared, we don't know what B squared is, equals 25 squared. Alright, so 7 squared is 49. B squared equals 25 squared is just 625. So now we've got to solve for B, so we're going to do DCI. Distribute. Is there anything to distribute? No. Is there anything to combine? No. So now we're doing inverse. The opposite of positive 49 is negative 49. So we've got to do that to both sides. That cancels each other out. So B squared equals 625 minus 49, and that is 576. Right, so we've got to get rid of this squared. So the inverse of something squared is by taking the square root. That cancels each other out. You're left with b equals the square root of 576, and that is exactly 24. So we know the distance from the ground to the window is 24, and it's meters. 24 meters high. Alright, that's just the solution right there. Alright, so the last problem that I want you to do, and I want you to write this in the text box when you submit this assignment. Tell me what A is. So you've got a triangle. You know one leg is 4. You know the hypotenuse is 5. So I want you to solve for A. Put what A equals in the text box when you press submit assignment.